Let's talk about complex numbers. Complex numbers, once again, serve the purpose of helping us when we have negative numbers under the square root. So as a quick review, if you ever have a case where you have a negative number under the square root, we can break this up into the square root of -1 times the square root of 4. And the imaginary number I is defined to be the square root of -1. So in this case, square root of -4 would be 2i. Now here's one of the interesting things about complex numbers. And I want to draw an analogy to something we've already covered in this class. Do you remember, if you haven't ever had an answer like this, 1 over the square root of 2, we learned that you cannot leave it like that. Matter of fact, we learned to do a thing called rationalizing the denominator. If you remember what we did, we multiplied the top and the bottom by the identical square root, so that 1 over square root of 2 ends up equaling square root of 2 over 2. The same principle applies with these complex numbers and with this imaginary number I. Say, for instance, the answer to my problem was 1 over 2i. Just like with radicals and square roots, we do not want to leave any i's in the denominator of a fraction. So anytime you have an I in the denominator of a fraction, you've got to get rid of it before you're done. Now the nice thing is, in this case, it's pretty much the same rule that we used with square roots. You notice up here I multiply the top and the bottom by the square root. You know what I'm going to do here? Multiply the top and the bottom by I. So the numerator becomes I, the denominator becomes 2i squared, but if you remember, what does I squared equal to? I squared equals -1. So I can replace that with the -2, and the way you normally probably write this is -I over 2, or sometimes they might like to see it like this, -1/2 I. All right, so when you have an I in the denominator fraction, it's the same principle as when you have a square root. As a matter of fact, if you remember, sometimes we had this kind of problem where you had a square root, not by itself, but it was one term and like a binomial. And if you recall, the way we got rid of that square root out of the denominator was to multiply top and the bottom by the conjugate. Remember, the conjugate means the same two terms, but you change the sign. So we first had subtract, now we have plus. So that if we work this out, this ended up being 4 plus square root of 2. And I'm going to do a little shortcut here. I know it's 4 square root is 16 minus square root of 2 square root is 2. 4 plus square root of 2 over 14. So that's review. Now, let's look at the case where we have 1 over 2 minus I. So now we still have an I in the denominator, but now it's not just a factor, but now it's actually a term in a binomial. Well, the good thing is, you do the same thing here that we did when we had a square root in the denominator as part of a binomial. You multiply top and the bottom by the conjugate. So I'm going to multiply the top and the bottom by 2 plus I. So in the numerator, I have 2 plus I. In the denominator, I'm going to use my shortcut again. You take the first term and you square, which is 4. You always write subtract, and then you square the second term. So 4 minus I squared. But now we recall that I squared is negative 1. So really in the denominator we have 4 minus a minus 1, which is like 4 plus 1. So 2 plus I over 5. Now, you think you should be done, but here's one more little quirk about imaginary numbers. Most of the time, when they give you a problem, they will tell you, express the solution as I plus BI. A plus BI. A is called the real part, and the BI is called the imaginary part. Normally they like us to give the answer as 2 distinct terms. You notice currently 2 plus I over 5 is all sort of one term. You know what I have to do? I have to split this up into 2 fractions. So what I have to do is to say it's 2/5 plus I over 5. And furthermore, here's the way they like to see it. 2/5 plus 1/5 I. So it's almost like if they want it in the form of A plus BI, it's like A is the 2/5 and B is the 1/5. So that's some of the nuances of using complex numbers. You can never leave an I in the denominator of your answer, but the good thing is the way you get rid of the I's are just like when you have a square root in the denominator. The exact same rules apply, so it's not that difficult.